Okay, question 7. So this f of x is a probability density function, which means that the area under the curve gives you the probability. It only exists from 0 to 4, otherwise it's 0. That which tells us that the integral of this from 0 to 4 has to equal 1. That's essentially how we do this first question. So we're going to say the integral from 0 to 4 of x over the square root of x squared plus k cubed, that's there, dx, this has to equal 1. Now it says show that, so you can't guys do something on anything on your calculator, anything fancy like that. There's a k in here anyway, so you've got a bit of a problem. So we're going to have to do this by hand essentially. So we're going to have to integrate this. How do you integrate something like this? Well, it has to be substitution, because I can see the derivative of x squared plus k gives me this x, which is kind of the telltale sign for substitution, and it's a quotient that I really don't like the look of, which is another telltale sign. You could be thinking integration by parts, but no, this is definitely substitution. So I'm going to let u equal to this thing here. U is going to be x squared plus k, and then when I differentiate it, du dx, I get 2x, which I want because that'll cancel with this x here. Just rearrange this, I get dx equals du over 2x. Now, substitute. I'm going to leave the x. I'm going to put here, well, actually, it's just going to be the square root of u cubed, because x squared plus k is now u, times dx, which is now du over 2x. These x's cancel, and I'm left with this. Note, guys, I have not put in the limits here deliberately because because I've changed to u. Really, I should either change the limits or put the limits back when I change back to x, which I'll do. So this is equal to, I'm going to take, the 2 is underneath the line, guys, so I'm going to take out the half. I don't like that half there. The square root of u cubed underneath the line is actually u to the power of negative, because it's underneath the line, 3 over 2, because it's the square root and the 3 is the power. Okay, du. Now, integrate this. This is a half times square brackets, raise the power by 1, so that's going to be u to the power of negative a half, and divide by the new power, divide by negative a half. Now these actually cancel, which is nice. So I'm left with negative u to the power of negative a half, which is actually just 1 over root u. So it's this, and that is equal to negative 1 over the square root of x squared plus k. Now I'm going to put back in my limits, 0 to 4. Okay, I'm then going to sub in my 4 and sub in my 0. If I sub in 4, I get negative 1 over the square root of 16, because this 4 squared is 16, plus k. And when I sub in my 0, so I'm going to do, just be careful here, guys, it's minus 1 over sub in 0, that becomes 0, and it's just root k. Okay, nearly done. This, remember, is equal to 1 from here, because we said the integral equals 1, and I need to show this, so I'm nearly there. This is just going to be plus this, by the way, guys, and, well, actually, I think what I'll do is I'll say this is, hang on, what am I trying to show? Okay, let's multiply. Well, hang on, let me just do this. I'll say this is 1 over root k, because it's plus plus, and then I'm going to add this to both sides. So I'm going to add this over here. So it's plus 1 over 16 plus k. Okay, nearly done. Then I'm going to multiply everything by root 16 plus k and root k, because I want to get rid of these denominators. So I'm going to multiply the left by root 16 plus k and root k, because that will cancel with this root k. I'm going to multiply the 1 by root 16 plus k and root k, and I'm going to multiply this by root 16 plus k and root k all over root 16 plus k. This cancels with this cancels with this, and what am I trying to show? This thing here. Let me just bring it down, guys. I am trying to show this. Let's put it here. So I have my root 16 plus k times root k on the right. It's there. I have my root 16 plus k on the left. It's here. All I need to do is subtract this root k, and I get root 16 plus k minus root k is equal to root 16 plus k times root k. Done. I'm going to write QED. So I've shown what they wanted me to show. Part B says find the value of k. Now, which basically means solve this equation. Now guys, this is where definitely lots of people would start trying to solve this by, I don't know, squaring both sides and trying to figure it out. That is not what you want to do. This is a paper 2, and I have a little saying, don't know what to do, is it paper 2? So remember, you have a calculator, and this is actually simple with your calculator. You just take out, well, I've already done it here, guys. So you go to NSolve, type in the equation exactly as you see it. Just be careful with the times and making sure everything's in the roots. Comma k means find k, and it just gives you the answer, 0.645093. K equals 0.645093, which is 0.645 to 3 significant figures. Now, hang on, it's 039, but whatever, it's still that 3 significant figures. Remember, the one thing, guys, is I always say be careful that it might have more than one solution. Now, you may notice that this function here is actually going to be a decreasing function if it was a function of x, and this function is going to be an increasing function. So as k gets bigger, this whole thing here actually gets smaller because you're subtracting this root k. And here, as k gets bigger, this whole thing gets bigger because you're just multiplying two numbers that are getting bigger. Graphically, it looks something like this. So this is this function, it's just getting bigger and bigger and bigger, and this is this function, it's actually getting smaller. So its biggest value is actually when k is 0, or x in this case. So because I know this is always increasing, this is always decreasing, they're only going to meet once. It's not going to turn and come back and meet again. So I know there's only one solution, hence that's the solution. Okay, that is finished.